All right, this says a particle moves on the x-axis so that its velocity at any time being greater than or equal to 0, is given by this function. At t equals 1, the particle's at the origin. So let's translate this into better notation. At time equals 1, so x of 1, to be at the origin means that your coordinate is 0. That's a little more math friendly. A says find the position of the particle at any time. Okay, your position at any time is your position when you started, and we know that's x of 1, plus how you changed from time 1 to time t under your velocity, of your velocity. Okay, so the particulars would be x of 1 is 0. The integral from 1 to t of my velocity function is 12w squared minus 36w plus 15 dw. Now again, that's totally legitimate. I think the intent of this problem, given the nature of this velocity function, is to get a closed form. And since I know the antiderivative of what's inside here, I'm going to do that. So this ends up being, so antiderivative of 12w squared would be 4w cubed minus 18w squared plus 15w. And we're going to evaluate that from 1 to t. Okay, so upper limit of integration, just turn the w's to t's. Minus, when you plug in the lower limit of integration, you get 4 minus 18, which is negative 14, plus 15 times 1. So you get a 1 here. Okay, so our closed form would be x of t is equal to 4t cubed minus 18t squared plus 15t minus 1. Question 2. Find all values of t for which the particle is at rest. So again, at rest means your velocity is 0. We have our velocity function up there, so I'm going to set it equal to 0. Okay, I can factor out a 3, so I get 3 times 4t squared minus 12t plus 5. So this is 3, so a little bit of guessing and checking and factoring. I think you'll get 2t minus 5 minus 1. Okay, that should work. So that tells us that t is equal to 1/2 and 5/2. Part C, find the maximum velocity of the particle on the time interval 0 to 2. So to find the maximum velocity, that's the max value of your velocity function. And we remember that max values occur at critical points and at endpoints. So to find the max value of v of t, we need to consider endpoints and critical points. So why don't I get my number line set up right away? Okay, I know 0 and 2 are endpoints. I need to find critical points by taking the derivative of my velocity function. So v prime of t is equal to, taking my derivative, right, my velocity function's up here, it's 24t minus 36. I set that equal to 0. And if you solve that, I believe you get t equals 36 over 24, which is 3/2. Let's put that on our number line. It's a critical point. Okay, now I can just plug in all these values into my velocity function and see which one's the biggest. I don't really want to plug in 3/2 if I don't have to, so let's see if that even corresponds to a max. It could be correspond to a min. So to do that, if I plugged in, for example, numbers, representative numbers on the left and right into my derivative here, I might just want to note whether I get a positive or negative. So if I plug in 0, for instance, into my v prime of t function, I get negative 36, which is a negative. And then if I plug in 2, for example, 24 times 2 minus 36 is a positive. So notice that means that there's a min here, and I can disregard it because the question asks for the max velocity. But notice that by the first derivative test, there are maxes at these endpoints. So I need to figure out which one is the absolute max. So I evaluate v of 0. That's easy. 12 times 0 squared minus 36 times 0 plus 15. And then I do v of 2. V of 2, I believe, is negative 9. You can double check that arithmetic, but I'm pretty sure it's negative 9. Okay, so our max velocity therefore must be 15. Okay, how about the next question? Find the total distance traveled by the particle from time 0 to 2. So the total distance traveled is just the integral from 0 to 2 of the absolute value of my velocity function. Let's be lazy and use technology for this. Okay, so I need my velocity function, so I'm going to hit math, fn int, I'm going to integrate from 0 to 2. I'm going to get my absolute value bars, and my velocity function, 12x squared minus 36x plus 15, 17. Okay, while we're here, we'll do the next one, which will finish this all off. Okay, so part E says find the displacement. So your displacement is simply the integral. Actually, so your displacement, remember, is a change in position. And it's just the integral from 0 to 2. No absolute value bars. Okay, it's got to collect net area or net change. So I'm going to duplicate this, and all I need to do is get rid of these absolute value bars, and it's the same structure. I might have to delete all this, though, one by one. Okay, so I punch in 12x squared minus 36x plus 15, and I get negative 10. Now, there are no units. This problem didn't give units, so I don't need to give units back. But obviously, a change in position could be feet, right? Total distance traveled could be feet, etc.